Dmitrowicz. Today we are starting a really cool unit. It's like, there's this crazy thing. You guys remember that atoms are like crazy small. Because they're so small, we have to do something.
Well, we want to be able to measure them, and dealing with like putting the mass of a single atom, putting it on a scale is just useless, right?
Yeah, you can't do it because remember guys, atoms are crazy small. Remember how small they are? Like, that's the number of blueberries in the earth, which is similar to the number of atoms in an orange. So that's like crazy. So how do we count things?
Well, let's use an example that we're all familiar with. Let's talk about the dozen.
Yeah.
So, Mr. Bergmann, you're a master of all units here. So how many things are there in a dozen? How many particles are there in a dozen?
Well, I bought some eggs the other day. I bought a dozen eggs, so that's 12 eggs.
We can use a dozen for anything, can't we?
Well, yeah, a dozen donuts.
Clearly you're referring to my girth. Yes, a dozen
I was
donuts.
not referring to you.
It works really well. But a dozen means 12.
Yeah.
And I never say, like if I just said, well, I have a dozen, you would be like, oh yeah, I know what you're talking about, because a dozen can have, at the end of it, any unit.
Yeah, a dozen flowers.
Yeah, so we did the same thing with atoms, and instead of calling it a dozen, we called it a
mole.
A mole.
And so the term mole references, it's like a dozen, except it's a different number.
And that number has a kind of like an AKA or an alias. We call it Avogadro's number. I'm guessing because Mr. Avogadro did some work on this, right?
Yes, yeah.
And this number is an extraordinarily large number.
It's really big. I think really big.
So
it is what?
6.022 times 10 to the 23rd, which if you're in calculator speak, that would be 6.022 E23.
Now, write that out like as a real number.
Are you gonna make me do this? 6.02200000000. I've gotten tired.
Okay, so yeah, 23 places after the 6. It is a really big number. Now, why do we have such a crazy big number? It's like a dozen, but why so big?
Because atoms are ridiculously small.
Oh.
And what's crazy about this is if we were to take, for example, a chunk of charcoal, carbon, right? And we took 1 mole of that, it would weigh approximately 12 grams, which is
just like a small handful. To give you an idea of how crazy big this number, Mr. Dmitrowicz, if I had a mole of watermelon seeds.
So if you had a mole of watermelon seeds, it would occupy the space about the size of the moon.
Dude, that's big.
It's crazy big.
That's crazy big. How about if I had a mole of donut holes?
Now you're speaking up my alley here.
Yeah.
It would cover the Earth, as much as I love that idea of a mole of donut holes, it would cover the Earth to about 5 miles deep.
5 miles
Pretty
deep?
much extinguishing life as we know it. Death by the best thing ever.
A mole of pennies.
That's actually crazy, because if you think about the distance from here to the moon, which is not nothing, right?
It's a long way.
You could stack pennies. You could have 7 stacks of pennies from the Earth to the moon, and that would be the number of pennies that we had, 1 mole.
But again, why is this number so small? Or so big, pardon me?
Because atoms are ridiculously small. And we're gonna talk about how actually small those atoms are, and I think we watched the video about that a little bit ago. But one of the things I want to emphasize here is that a mole is, like we said, we're going to talk about this a bunch, a mole is just like a dozen. So when I say a mole, you're immediately going to think 6.022 times 10 to the 23rd. They are combined. It doesn't matter what you put at the end of it, because we get in the habit of like, well, we're in chemistry, so it's a mole of atoms or a mole of molecules. But I could have a mole of donut holes. You know what that would be? 6.022 times 10 to the 23rd. In fact, while you're watching the video right now, you might want to just pause it and say this number a few times, 6.022 times 10 to the 23rd, because it's that important of a number.
In fact, at some point, guys, we're going to celebrate Mole Day. And when is Mole Day? You know this, of course. It is at 6:02 a.m. on 10/23. Expect some fun on Mole Day.
And by the way, I'm not sure if we do this that day or not. Do they get their nerd tattoos right after that, or how do we celebrate that they've joined us with this?
Wait and see, and you're going to see something amazing.
It really will be.
And one last thing, Mr. Dmitrowicz, how do we abbreviate, or how do we write out the unit, the mole?
So instead of saying, 1 mole, this is how we say it, 1 mole. But the abbreviation for mole, and imagine the amount of time this is going to save you, is MOL.
So 1 mole is equal to 6.02 times 10 to the 23rd things, whatever the things are.
And we call it things, we could call them particles. I call them particles because we can put in the place of particles anything we want to. And by the way, this right here, doesn't it look like a conversion that we've dealt with before?
Yeah, it is a conversion factor. And usually I would just say particles here.
Yep.
which could be atoms, because we're usually counting up atoms, but could also be like what we call formula units when we have a compound like we learned in the last unit.
Molecules, or donut holes.
Or donut holes. Hey, that's all we got for you on this one. We'll see you in class.
Indeed.